Morning, everyone. Welcome to another Learning at Lambert Labs session. And this week's presenter is Amelia. So I'll now hand over to Amelia.
Great, thank you very much. So I'm Amelia. I'm going to be talking about interacting with C code from Python. So Python as a language interacts quite a lot with C. I mean, the interpreter itself is written in C, so it's quite closely coupled in a lot of ways. We touched on this a bit with Aaron's presentation from last time. And personally, when I've been working with Python, I've heard a lot about these sorts of interactions. I've never actually done it myself though, so I decided to investigate. So first of all, what reasons are there for trying to call C code from Python? Firstly, the first reason is probably performance. C is a much faster programming language because it's compiled rather than interpreted. Additionally, C is also able to make much better use of parallelism or multi-threading than Python because it's not restricted by the global interpreter lock. Secondly, it's possible that in part of your application, you've got some legacy code written in C. It might be very labor intensive to port this all to Python just yet. So maybe for the time being, you could keep your C code the way it is temporarily and then call it from Python rather than porting it all straight over. Call it from Python, that is. And thirdly, C is a very old language. It's got a large number of libraries, and these libraries are very well supported. So maybe you want to access the features of a specific library which is written in C while keeping most of your application in Python. So what options are there available to do this? There's a couple of fairly easy options to get into. The first is importing the ctypes module. And then the second one is actually creating your own module from scratch written in C. So I'll get into the ctypes module. So ctypes is a built-in module, so you don't need to install it. It's a pretty core part of Python. It requires very little modification to your Python code or your C code. And the biggest change that's likely to happen is that you probably need to add some type annotations to your Python code. This is so that types can be converted properly from C to Python and vice versa. It will, however, require an extra build step in the form of compiling your C code to a shared library. So depending on your process, this might be a bit of an inconvenience. But one upside of that is that this technically doesn't restrict it to C code. Anything which can be compiled to a shared library should be able to be called from ctype. So that also includes C++ code, for example. Okay, so I'm going to do a little demonstration of how to use ctypes. Here we go. So on the left, I've got the Python code, and on the right, I've got my C code. So the first thing I have to do is import ctypes, and then I load the shared library into an object that sort of behaves a bit like a Python module. It isn't, but we can sort of think of it that way. And then if you're calling a very simple function, it's very easy. You just call testlib.helloworld, and it calls this C function here. Let me compile first and I'll show you. Yeah, okay. Yeah, that's fine. So I'm going to do Pythons. Okay. I should probably do that from here then. Yeah, there we go. Hello world. So calling a very simple function like this is quite easy. Where some more restrictions start to come into play once you need to, for example, see a double in ctype, a double precision floating point number. But even then, all it requires is this annotation here. So you reach into this object within the library and you set the response type to ctypes.c double. And this corresponds to the double return type of this C function. So if I run that again, or I'll run the next step, you can see it's calculated pi, 3.14159, etc. And then additionally, you're going to need to annotate both response types and argument types. So here in this function, I'm calculating E, that is like the constant E, and the input is a number of terms as an integer, and the output is again a double. So the response type is the same, but the argument types, it's a list of one element, which is an integer corresponding to that integer there. So here you can see that there is a little bit of extra work you need to do on the Python side, but really this C code is exactly the same. There's no restrictions placed upon it. And quite importantly, you don't have to access the Python interpreter. So you're not acquiring the global interpreter lock. And I'll just show you that third step working to calculate E. There we go. So that's ctypes. It's fairly easy to use, I think. And then I'll go back to the presentation. And then your other option is creating your own Python module in C from scratch. So this has a bit of extra work that you need to actually be building your Python module. And additionally, it does require some modifications to your C code. So in particular, it requires a few calls to the Python interpreter, which means acquiring the global interpreter lock. So some thought may be required to the design of your code. If you're using it to access legacy code you've written in C, this means you will have to add wrappers. So it will require a bit more effort for this method compared to using ctypes. However, most calls to the Python interpreter will just consist of passing function arguments and building Python objects to return. So it's really just type conversions between C and Python. There shouldn't be too much extra usage of the Python interpreter API. However, the result is much nicer for your Python code. So this module you make can be imported and used just like any other Python module, which means that for the end Python programmer, it's actually much more convenient. So it's about your priorities, basically. Whether you want it to be easier to use for the C programmer or easier to use for the Python programmer. And then I can show you that in here as well. So to build your Python module, this is a fairly simple script that will build a Python module for you. And it uses this extension feature to build your Python module from a C file rather than Python files. So if I go ahead and do that now, So that's just built it for me there. And if I do pip freeze, I've called the module, the name is my module. And if I look at my pip freeze, it's here, Python my module. Yeah, so that module consists of this C code on the right here. So I'll go through this step by step. So the main interesting part is this function here. And this is just a function to calculate the logarithm in base 2 of an integer. So like I was mentioning before, you've got one call to the Python API to pass an unsigned integer. So it takes the integer from this args parameter. And this capital I means that it's specifically an unsigned int. And this parameter here specifies the location where it gets placed in the result. Then it does this, it does the logarithm base 2. So it basically finds the highest set bit. So it's not very precise, but it works for integers, which is good enough. And then the other call to the Python API is this pylong from long, which constructs a Python integer from a C integer. So really, when this module is being used, these are the only two calls to the Python API you should need. And then everything in between, you can put whatever C code you want in the middle. Then the rest of the file is just the necessary definitions to set up the module so that it can be called from Python. This list here is a list of methods that are contained in the module. So I've only got one at the moment, and it's a method that's called logarithm2. This is the function pointer to the function that, the C function it refers to, i.e. this one here. This specifies how it takes its arguments, this, and the final parameter is a short description of the function. Then there's this sentinel row in the list, which basically marks the end of the list for the C library. And then you have one data structure which defines the actual module itself. And yeah, it contains the name of the module and a list of the methods that are in that module, plus a couple of other parameters, which we're not going to get into. And the final thing you do is you create your module here. So I've already shown it being built here. Yeah, cool. And just to check, if I do this, I can do import my module. And if I do a directory of my module, you can see it's got all the usual module fields, and it's also got this function here. So here's my Python code, which uses the module. And it's got a list of powers, and it goes through the list of powers of 2, and it computes the logarithm using C code. So let's try that. There we go. Yeah, so you can see it's accurately got all the logarithm base 2 of the entire list. Yeah, okay, so that is so those are the two main easiest options for calling C code from Python. I hope I've sort of explained a couple of their disadvantages and advantages. And are there any questions?
I've got one, Millie. When you're in the second example, when you're creating the Python module or Python package,
Yeah.
how does it work in terms of? I mean, it looks like so far you demonstrated using the logarithm, calling the Python API from C, right? As I understand. I'm just interested in like Python versioning here. I guess I don't really understand the versioning. You run the setup.py file with one version of Python, which is local to your machine right now.
Yeah.
On line 2 there, you're including python.h, which presumably is some sort of C library or with the Python API. But my question is, do you need to have close control of, or how do you control the version of Python that you are the version of the Python API you're using, I guess?
That's a good question. So I believe this C code that you're including here is the same C code that's going to be used by your command line Python, right? Because when you call like the Python command, I'm pretty sure it's going to end up calling this. It's going to include this same Python C file.
Okay. Yeah.
But then if you have multiple like installations of Python, I'm sure you can find this individual Python header within each installation. So I'm sure you can specify a specific like path to my Python here.
Yeah. Okay. Nice. Thanks.
What's an SO file?
Yes. Okay. So it's a shared object. So it essentially contains the instead of like, so it compiles the C code to a binary, but the shared object like contains the binary such that it can be accessed by other executables.
Okay, and how's that compiled? Is like a special command?
So it's this, I use this compile script here. It's a call to GCC with a couple of parameters to specify it's a shared, yeah, there you go, to specify it's a shared object.
Okay, fine, yeah, makes sense.
I got a couple of questions as well, Millie, if that's all right.
Yeah.
When you were using the Ctypes module, when you were adding annotations to the functions in C, and you kind of, I think on one function you annotated the return type as a double.
Yes.
Out of interest, what would happen if you change that to, say, a C unsigned int, or would it try and coerce the return type at runtime when you use that function, or would it just return an error?
So I don't think it would do either. I think it would, well, we can try this, but I'm pretty sure what it's going to do is it's going to read from the same location in memory, but interpreting it as an unsigned integer instead of a double. So it will give you an unsigned int, but it will be the binary data of the double. So it will seem like a completely random number. Let's see. So on this one, we're going to say we'll just make an int or something. And we'll say, oh, I don't think I saved. Yeah, so it's set pi to 5, which is, it's basically just mashing up binary data in the wrong format. But yeah, I mean, that is a problem. It won't throw an error. So you could quite easily have this bug occurring in your code without the software failing fast or behaving like silently when you want it to be loud.
Yeah, I mean, I guess you could argue that's the role of a unit test, but yeah, no, I suppose, yeah, it is quite annoying. I suppose like one thing I'm looking for is it would be really nice on line 4 or line 12, kind of two things really. Can it compile, can you import directly the C source code and compile it on line 4, as opposed to just importing the shared object file? And like, is there a way you can look at that C code and kind of automatically generate those return types?
So I think, so the way this module works is it works off shared objects. So I don't think this module itself can do that, because by the time it's compiled to binary, that type information is lost. But I think it's a good idea. And when I was working on this example, actually, one of the things I thought was, would it be possible to use Python type annotations, like existing ones? For example, something like this. Would it be possible to like generate these type annotations from existing Python ones? I thought that might be useful.
Kind of
but
like
no,
a
I think
Python header file.
Yeah, something like that. Yeah. But yeah, within ctypes as it exists, I don't think that's possible.
Cool. Thanks.
Great. Is there anything else anyone wants to ask?
Not from my side, Millie. Thank you very much.
Cool. Thanks a lot.
Okay. Thanks for listening, everyone.